Okay, so let's look at a few more questions from the problem set in lesson 8. We're going to do some from the back half of the problem set. I think these are a little bit easier than maybe the first 6 were. So yeah, hopefully you're getting better at these. Ignore the fact that my paper says 1, 2, 3 here. I think we're going to do, how about we do question 8? And so question 8 right here at the top of the page says, a number is 1/7 of another number. The difference of the numbers is 18. And it says that we should just assume that we're subtracting the smaller number from the bigger number to find the numbers. So usually, and I think every question we've done so far, we always wind up building an equation that we add things up and then it's supposed to equal something. This one says the difference, and so we're going to subtract the numbers this time. And when you subtract 2 numbers, if you reverse the order, like if you subtract the bigger one from the smaller one, you wind up with the exact same difference you would get if you subtracted the smaller one from the bigger one, except you get the negative version or the additive inverse. So essentially, when it's saying assume that you're subtracting the smaller number from the larger number, that's really just another way of saying that your answer should be positive. So I'm going to define my variable first, like I always do. And so x is going to stand for, well, the number we're trying to find, right? X is the number. And it says that a number is 1/7 of another number. So there's this other number, we can call it, I guess the smaller number, if this one is going to be 1/7 of it. So the smaller number will be 1/7 times x. Another way you could have written that is x over 7. These two things are equivalent here. And so the problem says that the difference between these two numbers, the number and the smaller number, is 18. So let's do the number minus the smaller number equals 18. And then let's write the expression on the left side of the equation in standard form, or in other words, combine the like terms. So 1x is the same as 7/7 x. In fact, I could even write that if I wanted to. I could write a 7/7 here, since that's just equal to 1, so it still just says 1x. I'm going to subtract 1/7 x, and so I get 6/7 x equals 18. And so now I want to start using the properties of equality to actually solve this. And I see multiplication happening here to the variable, the fraction 6/7 times x. And so we're going to undo that with the opposite operation. We're going to divide by 6/7 on both sides of the equation. And so if you multiply a number x by 6/7, but then you divide by 6/7, you're right back where you started at just x. And x is going to equal 18 divided by 6/7. But I'm going to write this as a keep change flip. 18 is the same as 18 over 1. Divided by 6/7, that's the same as multiplying by its multiplicative inverse, 7/6. And then we just multiply straight across the top. 18 times 7, well, let's split it into pieces. 7 times 10 is 70. 7 times 8 is 56. If you add those two things up, you get 126. Right? Now I'm second guessing myself. 70 is 56. Yeah, 126. And 1 times 6 is 6. And so now we just have to figure out what 126 divided by 6 is, and we can do this in pieces as well. 120, like forgetting the 6, if we divide that, forgetting this 6 in the one spot on the top is what I mean. So 120 divided by 6 is 20, and then if I divide the 6 into the last remaining 6, that's 1. So this is 21. So the number, the larger number, was 21. So I'll write that over here. X equals 21. So the smaller number well, that equals 1/7 times 21 over 1, which is 21/7, or 21 divided by 7, which is equal to 3. And we see that our solution works here because the whole point was the bigger number minus the smaller number was supposed to be 18. And I think you can see that 21 minus 3 is 18. So there's the two numbers we were looking for. Let's see here. Which one should I do next? How about number 10? It's an age 1. So it says, Kevin is currently twice as old now as his brother. Okay, so they're telling us a little bit about Kevin. He's twice as old. They're telling us nothing about his brother. So I'm going to make the variable b for, I don't know, I don't like using capitals. Let me change that. Lowercase b for brother's age. Let me move this up a little bit. And so it says that Kevin is currently twice as old as his brother. So Kevin's age, we have to write in terms of b. We can't make a new variable k for Kevin's age. We have to write Kevin's age with a b. And if he's twice as old, well, that's just 2 times b, or 2b. All right, and what else does the problem say? If Kevin was 8 years old 2 years ago, how old is Kevin's brother now? Oh, well, this actually makes the problem easier. If Kevin was 8 years old 2 years ago, well, I think just based off that, he must be 10, right? If you were 8 years old 2 years ago, you have to be 10 now. So Kevin equals twice his brother's age, but it also equals 10. So we can have like a multi-part equation here that says that all three of these things are equal. Okay, how old is Kevin's brother now? Well, this is actually a pretty easy one. I should have chosen a harder one to do for you. You know what? I'm going to move on to a different one. I feel like you should be able to write an equation and solve this one without my help from this point. I think it's worth my time to do a more difficult one for you. How about number 11? It says, the sum of two consecutive odd integers is 156. So consecutive odd integers, that would be like, well, if one of the odd integers was 3, the next one would be 5. You have to skip 4 because it's not odd. And the next one after that would be 7, and the next one after would be 9. So these are consecutive odd integers, essentially just skipping the evens. And if you think about, if you had one odd integer, like let's say you had the number 5, and you wanted to figure out what the next odd integer was using a math operation, well, you would just add 2, right? To go from 3 to 5, you add 2. To go from 5 to 7, you add 2. So we could make a variable for number 11. Let's call it n. Lots of times we like to use n for integers. Let's have that be the smallest of these integers it wants us to add up. There's supposed to be 2 consecutive odd integers, so smallest odd integer. And that means that n plus 2 must be the bigger odd integer. And then it says the sum of these two things has to be 156. So what are the numbers? So we just write an equation that says the smaller integer plus the bigger integer has to equal 156. We combine our like terms on the left side, write that expression in standard form. You ought to be able to solve this one from here without my help too. And number 12. It says, if n represents an odd integer, so it's a super similar question. Write expressions in terms of n that represent the next 3 consecutive odd integers. Okay, so it's really the exact same thing as 11, just more parts, more integers. So n can still equal the smallest odd integer. And then for the next one, it'll be n plus 2 to go from the smallest one to the second smallest one. We can call that second smallest. I'm going to abbreviate odd integer as OI. And then there's a third one, and that'll be 2 greater than the one we just had. So to go from the smallest one to the second smallest, we add 2. To go to the next one, we add 2 from there. And so we could write n plus 2, but I think it's pretty clear to see that that's just n plus 4. And so that'll be I guess we could either call this the third smallest or the second biggest odd integer. I'll call it the third smallest, maybe just because that's the weirder way to do it. I feel like being weird. And then to go one more odd integer from there, we'd have to add another 2. So instead of n plus 4, it's n plus 6. And we'll just call this one the biggest odd integer. And now we have to add all these things up, right? Is that what it says? If the 4 consecutive odd integers have a sum of 56, find the numbers. So these are going to be small numbers. If we're adding 4 things up and it only comes to 56, these things are going to be like 11, somewhere in that range. So let's write an equation adding all 4 of these things up. We have n plus 2 plus n plus 4 plus n plus 6. And that's all supposed to equal, I already forgot, was it 54 or 56? 56. And so let's combine our like terms on the left side, write it in standard form. 1, 2, 3, 4. I have 4 n's. And I have 2 plus 4 is 6, plus another 6 is 12. Equals 56. And I'll actually go ahead and finish solving this one for you instead of just leaving it for you. So I'll subtract 12 from both sides because I see a plus 12 here, and I want to use the additive inverse to essentially make those go to 0 or cancel them out. And so these 12s go away, and I have 4n equals 56 minus 12 is 44. So I see 4 times n. I want to undo that with division. So I will divide both sides by 4, and I get n equals a. I called it. I honestly did not know that was going to be the solution. I just kind of guessed. All right, so the smallest one is 11. That means the next biggest one must be 13. The next biggest one must be 15, and the biggest one is 17. These are the integers. Oops, I should have written are the integers. And we can check by adding them up. Does 11 plus 13 plus 15 plus 17 indeed equal 56? I'll let you do that. All right, that's it.